Alright, so let's make the continuation of our 2022 Paper 1 ECZ questions 9, 11 and 13. We'll look at questions 9, 11 and 13. So to get started, number 9 reads as follows. The matrix M, we give the matrix M as 1, 5, 2, 7, and the matrix N as 0, 1, 2, 0. So then, matrix M has got 2 rows. Remember, a matrix is defined by its rows and columns. Rows are horizontal. These are horizontal elements which we are able to see. In the first row, we have 1, 5. In the second row, we have 2, 7. Whereas the columns are the vertical entries that we're able to see here. In them, we have got 1, 2, 5, and 2 columns. Alright. And 2 columns. The transpose of matrix M. This M to the power T, this notation is read as the transpose of matrix M. The transpose of matrix M. Now, what is the transpose of a matrix? The interchanging of rows and columns. So, in the case of matrix M, we see that matrix M has got 2 rows. These 2 rows we are seeing, will become the 2 columns. That's what it means, transpose. If you transpose a matrix, that's basically what we are talking about. I'll give an example. I'll give just an example having A, B, C, and D. Here we have got 2 rows. Now, the solutions. As in the transpose of matrix M, this will be in the first row will become the first column. And in the first row we have 1, 5. So here we write 1 and a 5. The row will become the second column. And in the second row we have the 2 and of course the 7. And this is the answer of matrix M and M. Meaning, we are going to multiply matrix M times matrix M times matrix M. And this will be as follows. Matrix M is what we write first. And matrix M is 0, 1, 2, 0. Matrix M is, let's get going. So we now want to multiply the 2. Well, we now want to multiply the 2 matrices. How do we multiply them? Well, in this matrix, the first row will multiply by each column in the second matrix. So listen please carefully. The first row will multiply by each matrix, by each column in the second right-hand side matrix. So we are saying 0, 1 will multiply by the first and second column. Once we are done, we shift our attention to the second row, which will do the same. I repeat, the first row in the left-hand side matrix, the first row will multiply by each column in the second. So in the first one, we're just concentrating on the rows. The second one is just columns. Are you there? Here. So it will be 0, right? 0 times 1 plus 1 times 2. 1 times 2. From there, we're going to leave a gap. Which gap is it? This gap we are able to see because we did 0 times this one plus 1 times 2, which you have here. Then leave a gap. Leave a gap so that this one now also multiplies with the second one there. And we'll say 0 times 5, and this is 0 times 5 plus 0 times 5 plus 1 times 7. Write 1 times 7 and close. Once we are done with this first row. Let's move on to the second row. Right here as 2 times 1, this plus 0 times 2, this will be 0 times 2. We once again leave this gap, which is this one here. Leave this gap so that we hammer this one. That will be 2 times 5 plus 0 times 7. We're going to have 0 times a 7. 0 times 1 is 0. So write the 0 here. Plus 1 times 2, that's a 2. We leave a gap, this is the gap we're leaving here. 0 times 5, that's a 0. Plus 1 times 7, that's a 7. We close. We come to this one. 2 by 1, that's a 2. Plus 0 by 2, that's a 0. We leave a gap, this gap here. We leave it here. 2 by 5, that's a 10. Plus 0 by 7, that's a 7.
0.
Alright, that's a 0, thank you. 0 times 7, that's of course a 0. 0 plus 2, that's a 2. So here we're going to have a 2. 0 plus 7, that's a 7. We're going to have a 7 here. 2 plus 0, that's a 2. 10 plus 0, that's a 10. And this becomes our answer. And B, lie on latitude 60 degrees south, while point C is on latitude 30 degrees north. So remember, this is earth geometry. And in earth geometry, I'm able to say about this globe. This is an example of the globe or the earth, whereby we've been given what we call the latitudes. And as you know, the latitudes run from east to west. So here, if you come up with the compass, you see that this side, this is actually eastern part. Okay, of this particular earth. This is the east, and of course this is the west. Then up there, that's where you have the north, and down here, that's where you have the south. So the latitudes, they run from west to east, east to west. Those are the latitudes. The latitudes are what we call here, these are actually horizontal, lines, okay? These are horizontal imaginary lines that run from east to west. Basically, that's about the latitudes. So in the case of this particular diagram, I've got two latitudes. I've got this one here, which is latitude 30 degrees north, and we have another one, which is latitude 60 degrees south. Okay, that's what we have. And the fact that we've got these latitudes are from different hemispheres. For example, this latitude 30 degrees is in the northern hemisphere. We see that this latitude 60 degrees is in the southern hemisphere. It shows that these two latitudes are on the opposite side of the equator. In other words, between these two latitudes lies the equator. Are you there? Okay, that's the whole idea of this one. The moment you see north, south, or different hemispheres, in between them lies either the prime meridian, if it's the longitude you're talking about, or it will be the equator if you're talking about the latitude. Actually, 4 longitudes. This longitude running from here all the way up to here. This longitude from here up to here. I've got this longitude here as well here. Another longitude, this one here, and the last one, this one here. That's what we have anyways. Remember, these are circles. These are circles. If you see this latitude here, we have got on the other side of it, it's dotted to say on the other world, on the other side of the earth. It's still continuing actually, because these are circles actually, not lines but circles. The local time at A, it is 10 hours at A, when it is 13 hours at B. So at point A, the time is 10 hours. At point B or town B, it's 13 hours. Now, how do you go about computing time? I want you to listen very carefully. Avoid, along the, great circles. That's one thing that you should understand. Time is measured along greater circles. And what happens here is that we have got two directions. We have got the eastern side and the western side. So as you move towards east, each time you're moving towards east, always time is always ahead. Okay, a place that is on the eastern part of the world is actually always ahead of a place, ahead in terms of time, ahead of the place that is on the western part. Always, that's how it is. So what are we saying? So when we're saying, as we move towards east, there is a gaining of hours. As we move towards west, there is losing of hours. That's the concept that I want you to do. The two times here. A is on the western side of B, and B is on the eastern side of A. So this one must be ahead in terms of time, ahead of A. No wonder we're able to say this is 10 hours, at A, and 13 hours at B. Are you getting? That's how behind, okay? Between A and B. Remember, time is measured on the longitudes. Take note, we use the longitudes for us to measure time. So what is the weak formula or the weak point for us to go about the measuring of time? So we use this time difference is equal to the difference in longitudes. Observe, difference, the formula that we actually have, where TD means time difference. Theta means difference in longitudes. Difference in longitudes. Different meter that we are seeing longitude between those places. In the case of this one, we're talking about the place A and the place B. That's what we're talking about. The difference in terms of longitude, where A lies, which is this one here, and the longitude where B lies, which is this one here. So that is the theta you're seeing here. 15 degrees. TD, that is the time difference. So then, remember, and in this case, the difference in longitudes, it is the theta, right? So then, what we do know here is, we don't know the time difference, and as well as this 15 degrees, but we do not know what theta is. But the question is, how do we get to find the time difference? Simple. If you look at it, can you fail to calculate the time difference here? This is 10 hours and this is 13 hours. What is the time difference? Are we seeing? You simply say 13 hours minus 10 hours. 33 hours. Explain it already. So simply subtract this from this one. That's the time difference. Write it in 3 into this. You do this here. 3 hours is equal to the theta, which you do not know, all over by 15 degrees, of course. Then you make theta the subject to the formula. If you do so, you're going to have theta is equal to 3 times 15. And this will equal to 45. Now, what 45 what? Remember, we're talking about the difference in longitudes. So this will actually be 45 degrees, meaning the angle, because we're talking about the difference in longitudes. And longitudes are circles. So this will be 45 degrees, and of course, Alright, so let's look at question number B. Question number B, we are now here given this scenario to say a plane flew, take notes, a plane flew from B to C. A plane flew from B to C at a speed of 600 knots. At a speed of 600 knots. The question asks, how long did the plane take? When the question asks you to say how long, they're simply talking about the time. How long did it actually take? If it was moving at 600 knots or 600 nautical miles per hour. Answer this one. So first of all, okay, so say given as distance over time. Now, here the question is asking us how long this plane actually takes. Here we put 600. and this will equal to the distance. How do you calculate the distance? Provided if and only if, how do you find the distance? If the speed was in knots, take note. If the speed was in knots, how do you get to compute the distance? In nautical miles, take note. The distance has to be in nautical miles. If the speed is in knots, then the distance must be in nautical. It's a question of how to define time. So we're saying first and foremost, we need to calculate the distance between point B and point C. We need to calculate the distance has to be in nautical miles. Now, how do we get the distance? Speed has been given actually in the question as 600 knots. Distance is what we must find. Distance we must find. Now, if it's in nautical miles, then the distance formula will be theta times 60 nautical miles. Whereby this theta is actually, the difference. This theta is the difference in latitudes between point B, in this case, between point B and point C. The latitude where B lies, it is this one, 60 degrees south. The latitude where C lies, it is this 30 degrees north. Now, how do we get the angle difference between them, which is the difference in latitude? How do we get this angle here? You simply check, this is 60 degrees south and this is 30 degrees north. We see that this angle and this angle are lying in different hemispheres. Now we have a concept to say, different hemispheres, if you are adding the angles from different hemispheres, if you have got angles from different hemispheres, the sum that we need to do. Different hemispheres, what we do with the angles, do you remember that? You had known here, you would have subtracted. Different hemispheres you add to get that theta of C. So in the case of this one, we add this latitude to this one. Of course, we forget about the north and the south. We simply add 80 degrees plus 60, which will be 90. The distance now will become distance, observe, distance is equal to this theta will actually be 30 plus our 60. Close times this 60 here in the formula. If you simplify this, we're going to have 60 plus 30, this is 90. 90 by 60. You may leave it here as your distance. You may choose to just leave it here as your distance. So indeed, this is the distance in nautical miles, nm, which is actually something that we want. Distance has to be nautical miles. But remember, the question is about how long. So the how long is basically the time. So then, once we do this, we are able now to come back with the answers. With this, we now know what the distance actually is as 90 times 60, which is, something that in this case we put a question mark. Once we do this here, we put this into our formula. So we're going to have, allow me to. So this is speed is equal to distance over time, where speed is 600. The distance is 90 times 60. I left it like that deliberately for easy computational calculations. So 90 by 60. Everything out of the time which I don't know. So in this case, I'll simply put x. Then I have to make x the subject or the formula. Then I simply do this here and cross multiply. The distance, this one is 600x. And this one times that one is 90 times 60. Observe. Here I want to find x, which happens to be the time. So I'll divide all over by 600. Also here all over by 600. I cancel this and cancel this. I put the x. And this will be x is equal to cancel, 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 cancel. Cancel, cancel. So I simply have got the 90. 90 what? 90 hours. How long? So, 9 hours, sorry. Yeah, it's actually 9 hours. And of course, this will be 9 hours there. So that was actually how long it took. How long this particular plane took 9, this 0 with this 0. Then I've got a 6 and a 6. So this 6 and this 6, they cancel out. So simply I've got 9 hours. Okay, so let's look at question 12. Question 12a, we are taught to find the gradients of the line passing through the points A and B. Okay, remember the gradients of the line passing through the points A and B. This is a straight line that is passing through point A and point B. We are given point A as 4,6 and point B as 2,4. So let's look at the solutions. M is given by y2 minus y1 over x2 minus x1. From there, you name these 2 points here. We know this 4 in this particular point is from the x-axis, and this is the x value. This negative 6 is from the y value, we name it as y. We move on to B. We have got 2, 4. This 2 is from the x-axis, and this will be x. And this 4 is from the y-axis, and this will be y. Once you do this, you name them as, and this one as ones. Once you do this, it's the matter of plugging these 2 points into the formula. So you check, y2 is your 4, minus y1. y1 is your minus 6. Everything divided by x2. x2 is a 2. You are following the formula. Minus x1. x1 is 4. If you simplify this, you have 4 minus 6 is 4 plus 6, which is 10. 2 minus 4 is minus 2. And the answer will be minus 5. Therefore, the gradient is equal to minus 5. At B, we're given the equation. The equation is 2x to the 3rd power. This is equal to 16. 2x to the power 3 is equal to 16. First and foremost, you need to find the x value, but how? We see that this x is together with this particular coefficient 2. So we get rid of the coefficient 2 by way of dividing. If you divide, we're going to have the 2 will cancel out. We have x to the 3rd power. This is equal to 2 into 16. It goes 8 times. At this point, you may express this one as the exponent, or you simply use the cube root. How do you use the cube root? Well, you use the cube root as this cube root here. Also, you introduce the cube root on the other side. This cube root and this 3 will go. So then we have the x. Yes, this cube symbol, this cube root symbol, and the power 3 will cancel out. So that we have the x. And the x is equal to the cube root of 8. What is that number? If it multiplies itself 3 times, it will give you 8. That's the cube root. And that is a 2. So the cube root of 8 is actually 2, because 2 times 2 times 2 is 8. And this is the answer. Alternatively, for you to find x, if you have x to the power 3 is equal to 8. For you to find x in this, you could use the indices. You need to reciprocate, you multiply by the reciprocal of a power. And the reciprocal of this 3 is actually 1 over 3. So you could also say x to the power 3 times 1 over 3. You do also on the other side. This is 8 to the power. This 8 is actually to the power 1 there. So you multiply, if you noted here, you multiply this 3 times its reciprocal. Its reciprocal is 1 over 3. You also do the same here. This is 1 times this same reciprocal which is being multiplied. Multiply it also on the other side. Once this is done, you go further. You say this is x to the power. And 3 times its reciprocal is 1. So here is just about the x here. And this will equal to 8 to the power 1 times this is 1/3. So I'm going to have 1/3. Then look at how interesting this is. X is equal to, we're going to break this 8 in such a way that if it's broken, its power will be 3. So this 8 can be broken as 2 to the power 3. Because 2 times 2 is 4 by 2 is 8. 2 to the third is 8. But we know there's a power and another power here. So this is 3 times 1/3. 3 times 1/3 to give us 1. So if you want to multiply this, you just end up and having 1. Therefore, x is equal to 2. 7. That's another one.